Okay, so the first problem that we will look into will be the bounded buffer problem after learning semaphores. Now, we will show a solution to this problem that is based on 3 semaphores. One semaphore is for protecting that we call mutex, that will protect shared variables in and out. So in the producer-consumer problem, when will in and out be shared variables? Or in other words, in assignment number 1, we did not use semaphores to protect in and out, and things worked out fine. Why?
Because we restricted who had access to in and out variables.
Okay, can you be more specific?
So producer was able to set it, but the consumer wasn't, and then consumer was able to set out, but producer wasn't.
Yeah, exactly. So in was modified only by the producer, and out was modified only by the consumer. Now, in and out will be shared variables if we have multiple producers or multiple consumers. So if we have multiple producers, in becomes a shared variable, and if we have multiple consumers, out becomes a shared variable, and we need to protect it. But if we have a single producer, single consumer, there is no need to protect in and out. In this assignment, in this solution, we will be protecting in and out with a semaphore because we will be assuming that we may have multiple producers and multiple consumers. Now, in addition to protecting the variables, now we need to synchronize access to synchronize access to the buffer. In particular, the point is to have the producers wait when the buffer is full, consumer waits when the buffer is empty. So we have 2 semaphores, 2 counting semaphores. One is the full count, which counts number of items produced but not consumed. In the buffer. And empty count counts number of what? It's called empty count. So what will it count?
So what's consumed?
Number of?
Consumed.
Well, not number of consumed.
Free buffer.
Yeah, number of free cells in the buffer, free entries in the buffer. Number of free or unused, let's call it cells in the buffer. So now, when the producer produces an item, what should it do with full count? Increment it or decrement it? So the producer should increment full count. So producer increments this. So let's say, okay, let's put it here. Producer will increment full count, and what should it do with empty count? Decrements empty count, because it consumes, it uses a free cell. So it increments full count and it decrements empty count. While the consumer, what does the consumer do to full count? What does it do to the number of items that have been produced but have not been consumed? It will be consuming an item, so it will be decrementing the full count. What will it be doing to empty count? What will the consumer be doing to empty count? Increment. Because it will be making one more cell free. It will be consuming an item, and that cell will become free. Increment, empty count. Now, in terms of semaphore operations, what does decrementing correspond to? Does it correspond to a wait or a post?
Wait.
Wait. So this is wait. When you wait, you consume. When a process waits, it waits until an instance of the resource becomes available, then it consumes an instance. And when it consumes an instance, that decrements the value of the semaphore. So the producer is going to wait on empty count. So it's going to wait if empty count equals 0. And it's going to increment or post full count. Why? Because it will make one more item available. And the consumer is going to do the opposite. So it's going to decrement, which means wait on full count, and it will post empty count. Now we can understand. Now we can look into the code. Well, first of all, what are the initial values? So what should be the initial value of full count? How many items do we have initially? 0. How many free cells do we have initially?
Buffer size.
Buffer size. Yes, exactly. Okay, so full count is initialized to 0 and empty count is initialized to n, which is the buffer size. Now, by the way, here we're trying to fill the buffer completely. Now we are no longer filling n plus 1. We're doing all of this semaphore stuff in order to fill the buffer completely. So now the producer code, the producer is going to wait on empty count. So waiting if empty count is 0, if there are no empty cells in the buffer that the producer can use to write to, then it's going to wait. Then it's going to wait on the mutex. Mutex is the semaphore for protecting shared variables, and shared variables here are in and out. And as we said in the beginning, in will be shared if there are multiple producers. Then it's going to signal that. So this is the critical section. Accessing the in and out is going to be our critical section. Then when it's done, it's going to signal full count. So it's going to signal or post full count because it's making one more item available. Consumer is going to do the opposite. So it's like it's going to wait on full count and it's going to signal empty count. And it will also wait on mutex. Now here, note that we are using the same semaphore to protect in and out. Is this the most efficient way of doing it? So when we are using one semaphore to protect both in and out, then we are saying that can in and out be modified at the same time? No, they can't, because they are protected by the same semaphore. So if we want to allow in and out to be modified at the same time, what can we do? What can we do in order to allow in and out to be modified simultaneously?
Use 2 semaphores?
Yeah, we use one semaphore for in and one semaphore for out. Using the same semaphore means that only one of them can be modified at any given point in time.